In this video, I will integrate cotangent square x, and I will do it in two ways. Now, let's talk about the first way. We call the method 1. Now, this is the same as integral of 1 over tangent square x dx, right? Okay. Now, what do? We cannot do too much here, right? So we have to rewrite the 1. Usually, tangent and secant pair well with each other. And we know that this identity, right? 1 plus tangent square x is equal to secant square x. Now we need a 1 here, right? So isolate the 1. 1 is equal to secant square x minus tangent square x, right? So we can replace this into the 1 here. That's the same as integral of secant square x minus tangent square x, or divided by tangent square x dx. And of course, I can break this up, right? So integral of secant square x over tangent square x minus tangent square x over tangent square x dx, like that. And of course, this is just equal to 1. So integral of course, I will just distribute the integral sign to each term, right? So integral of secant square x over tangent square x dx minus integral of, that's just 1. 1 times dx is dx. Okay. Now this term, right away, we know the answer is x, right? So we can write this. That's equal to integral of secant square x over tangent square x dx minus x. Now we have to integrate this. And this is easy to integrate as well, because tangent and secant pair well with each other. And now I can just let u equals to tangent x, then du is equal to secant square x dx, right? So I can replace this with u squared and this with du, right? So I'm integrating 1 over u squared du. And that's the same as integral of u to the power of negative 2 du. Add 1 to the power divided by the new power, that would be this. And that would be negative 1 over u. And u is tangent x. So that would be equal to negative 1 over tangent x. And that is the same as negative cotangent x. Okay, so here. So that's the answer for this. So this is equal to negative cotangent x minus x. And we're done. Plus c, right? So that's the answer. Okay, let's do it in method 2. So we call that method 2. Now, that's the original integral. We can rewrite this as integral of cosine square x over sine square x dx, because that is cotangent square x, right? This way is good too, because sine and cosine usually pair well with each other. So what can we do? Now we can rewrite this, right? That's equal to cosine x over sine square x times cosine of x dx. That's the same thing. Cosine x times cosine x is cosine square x, right? Why do I do this? Because I can easily differentiate cosine x or integrate cosine x too. But with this, I can easily integrate this. Okay, so I will use the integration by part formula. In that case, I will let u equals to cosine of x, right? Then du is equal to negative sine x dx. Then of course, dv is equal to cosine x over sine square x dx. Then v is equal to, what's the antiderivative of this? Now think about it like that, right? Let's say we're integrating this. Now, I already used u here, right? So let me use a different letter, right? Let me let k equals to sine x. dk is equal to cosine x dx. Now I can replace this with dk, right? So this integral just become this. Integral of 1 over k squared dk. That's the same as integral of k to the power of negative 2 dk. Add 1 to the power divided by the new power, we have negative k to the power of negative 1, right? That's the same as negative 1 over k. And k is sine x. So this is negative 1 over sine x, which is, okay, leave it like this. So that is negative 1 over sine x. Now, the integration by part formula, right, is this. Okay, what's u? Cosine x times v is negative 1 over sine x. Minus integral of v, so here, times du. And du is negative sine x dx. Okay, so this is negative cosine x over sine x. Now minus, now this and this cancel out, right? And this cancel out. Basically integral of dx. And that's just equal to x, right? And this is negative cotangent x minus x. Okay, so that's the integral of this, right? Here, which is the integral of cotangent square x. Okay, we're done. We can add c at the back. Okay, notice that the answer is the same. Here. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.